one of the observations here was again the use of collaboration combined with information modeling was really changing the way that they were doing their work. This in conjunction with very, again, tight constraints on site, and it was a very inspiring submission. The jurors, I know, have lots of questions teed up for this one, so I'm looking forward to seeing the presentation and hearing the discussion. So with that, I'll turn it over to Colin.
Thanks very much. Good afternoon, everyone. Firstly, a couple of words about myself. I'm a chartered civil engineer and a fellow of the Institution of Civil Engineers, and I've been working on the project and up until this summer for about a period of 4 years. Started as a construction review role before the contract was let, and now it moved through into the contract stage where I worked for the contracting organisation. And more recently, over the summer, I've now become a stakeholder. This is a station that I use every day, and I'm now one of the people that curse all those people in hard hats, disrupting my way to work. It could also be said that I'm a part funder for the client as well, because it's paid for out of our taxes, of course. This is Victoria Station in London. You can tell this is an artificial visualisation because at no time is it ever this quiet. This area certainly is not free of people any time I've seen the station. So we're going to do a little bit of a project overview, and we're focusing on one area of the project, and that's treatment of the ground. Some of the challenges that we've come across so far on the project, and how we've used BIM in the design of that ground treatment process, and also a little bit in how we've used it in the construction of that ground treatment as well, and then a quick summary at the end. So just a little bit about the organisation of the project. The client is London Underground. They're obviously an owner of a railway in London, but they're also an operator, and they're also a maintainer of that railway. So they're a construction client as far as we're concerned, but it's very much about keeping that railway operational and open for public use. It's a bit like operating on a patient, but they're actually kept awake. I think it's one way of looking at it. The contracting organisation is a joint venture between Taylor Woodrow-BAM Nuttall, and the designers for the project originally started working for the client, and now they've been novated over to the contractor as Mott MacDonald. And the supply chain partner who's actually undertaken the jet grouting is Keller. So the objectives of the project, if we just have a look at that, it's to address the congestion of the station. Every morning there's just too many people trying to go through the station. There's forced closures of the station at peak times to maintain safety for the customers using the station. There's just literally not enough space for them to all use it. Currently, Victoria is a transport interchange, so there's a mainline station, an underground station, buses, coaches, and there's around 80 million people pass through there every year, which is more than Heathrow Airport. And that's forecast to rise to around about 100 million over the next few years. And it's just unsustainable to try and keep that station running and do nothing. So as I say, we've got to keep that project open as well as upgrade it at the same time. Another one of the objectives is to provide step-free access. This station is one of the main links from Gatwick Airport, so you can imagine step-free access is not just about people in wheelchairs or impaired mobility, but you've got people coming off aeroplanes, suitcase in either hand, and they're met with a set of stairs to get down to the underground railway. Obviously that's just not sustainable these days. Also, the Victoria Line upgrade, which is an upgrade of the rolling stock and operation of the railway itself, enables more trains to go through the station. And of course, more trains makes it a better service, but also moves more people through the station as well. So this is what Victoria Station looks like at the moment. It's not really a 7 or 8 year construction project, it's really a 100-year plus project. Firstly, we had the District and Circle line here, which was built in the late 1880s. It's fairly shallow, it's built in open cut. And then the deeper Victoria line here is built down in the London clay, built in the 1960s. And then there's these existing escalator ways and passenger subways. So there's a lot of the ground is actually filled up with assets already. And then the proposal, the difficult bit is trying to find space to actually build it in that's not already occupied. But what we're going to do is extend this ticket hall that exists at the south end here we're going to provide a new ticket hall at the north end. This is currently under a road, so there's to be a structure built underneath an existing road. And then it's all about moving people along these platforms. There's congestion along the platforms because all the escalators come down one end. People aren't using this north end of the platform. So the idea is to distribute people along this platform and obviously provide more space for them to circulate within the station. So the scope and the benefits. So enlarging that south ticket hall, there's anecdotal evidence that one of the escalators is the second busiest in the world. I hate to think what the busiest one looks like in the morning rush. There's the new North Ticket Hall, as I said, to provide additional access into different parts of the station. And also to service, there's a lot of commuters in the evening rush that come along Victoria Street. Actually, that would be their preferred entrance into the station. It's all about reducing journey time as well. There's various calculations that will tell you how much it costs for passengers to spend every minute walking their way through the station. And there's various programs that calculate that, but that can rack up into millions very quickly if they're stood waiting, unable to use the station. Also, reduce station control. Obviously, as an operator, it's unacceptable to London Underground that they have to throttle back the usage of the station. They want to enable their customers to push through and use the service. Improved ambience. Some of the station is looking a little bit tired now. Some of it's a little bit claustrophobic because obviously there's a lot of legacy there from when it was built with a much less passenger usage. Step-free access. More and more stations are now being upgraded to enable accessibility for all passengers, and obviously new stations have that built in as a matter of course. And better emergency access. As you can imagine, if trying to evacuate the station but also provide access in for the emergency services is very difficult. So there's a dedicated access route being provided as part of the project. And also it's a catalyst for regeneration. If you've got a station that can move people through it efficiently, then people will come. So this is a little bit of an overview of the station that's taken from the model with a little bit of artistic license from the architects to provide a bit more shading of what's there. We've got a series of structures to build underground. We've got some mechanical plant to put in. We've got new escalators. We've got new lifts to provide step-free access and also dedicated fire access so that if the station is evacuated one way, the fire have got emergency access in as a separate route. And we've got these new passenger tunnels that link the various areas of the station together to improve the passenger flow from one part of the station to another. So the ground treatment. Well, as I said before, the difficult part is to find space where there is not already, the ground is filled up. The easy part was the shallow excavation in the 1880s. They took the shallow land at the surface. And then in the 60s, they went through the London clay, which some say is the perfect tunnelling medium. So there's only a little bit of space left in between those. And the idea is that a lot of those passageways are part in the clay and part in the gravels. Obviously, gravel is no good for tunnelling through. So what we need to do is treat that ground before the tunnelling operation. To give you an idea of the scale of work, the ground treatment itself is around £37 million. So it's around about half of actually the total cost of constructing those tunnels. There's in excess of 2,500 jet-grout columns which is required to treat the ground. And it's also a critical path activity. One of the items we identified earlier on is actually the real cost on a project, obviously, is when you start to mobilise plant and materials and people. And this activity is on the critical path. So what we did is we sort of separated the preparation side from the actual jet grouting itself to give us a little bit of extra space on the critical path. And really it's unprecedented on this scale. Jet grouting has been done before in the UK and around the world, but really on this scale I think it's unprecedented. One of the biggest challenges was obviously drilling holes from the ground surface, avoiding all the utilities, services and existing tunnelling assets that are in the ground already. And of course keeping the station operational. So a quick overview of what jet grouting actually looks like. Firstly, there's an initial protection sleeve that's installed through the services to ensure we've got a clear, safe route through those services. Then the drill rig sets up. The spore return duct is installed through that inside. So it's a physical metal tube that's installed inside that initial protection sleeve. Then the rig drills down to the full depth, so it's through the silts, the gravels into the London clay. It pre-cuts the clay twice to form the actual diameter of this column. Then it pre-cuts the sand and gravel above that. Finally, the silt layer which lies above that. And then the jet-grout column itself is installed. So essentially it's a weak concrete mix that it creates in the ground. So instead of a pile, if you like, from the surface of a constant diameter, you've got a smaller drill string, and that forms a large interlocking cylinder, interlocking with its adjacent cylinders in the ground. So it's a series of vertical cylinders but also inclined cylinders because of the various constraints that exist in the ground. It creates a fairly weak concrete mix that's suitable for tunneling through, yet it provides sufficient strength to support the face. It's a 400 bar operating pressure, so it actually liquefies the ground during the process and replaces it with cement and water and grout mixture, and mixes that with the existing ground to form that concrete. So it strengthens the ground, it provides a full face treatment of the ground when you're tunnelling, and also forms a barrier to keep the groundwater out, which the London clay does as a matter of course. The challenges that we have there, traffic routes. There's a bus station within the heart of the project. There's a coach station nearby which has coaches going all over the country. And then you add into that the taxis serving the station, and also the buses and cars. This is the main through route sort of north-south through this area of Victoria Station. Also pedestrians. All those pedestrians either go down into the tube station as they come off their commuter trains, or they walk into the neighbourhood. There's lots of government offices and private companies in the area, and there's a huge amount of pedestrians that you have to keep moving through the area. This view here is what it actually looked like over the summer. We had a bit of a sporting competition in town that affected quite a few projects in London, and we actually had to reinstate this area. So obviously there was no effect on moving people through the station. As I say, it's a key transport interchange, and it's unacceptable to have any adverse effect on that. So this is what the actual process looks like. I think some of the guys thought they were archaeologists in the way they had to excavate around these areas. But the only way of doing it is this sort of rather cumbersome sort of pothole and trial pit exercise. You can do a certain amount of scans, but you have to know for certain exactly what is in the ground and where it is. So we inserted all these plastic protection sleeves in between all these surfaces. And there's also lots of other structures in the ground as well, sort of abandoned structures that have been uncovered that aren't really on any record drawings. Also the sequencing. In order to keep that traffic run, you can only work on a fairly small area of the road at a time. So once you've opened up that parcel of traffic management and exposed the services, you really just have to get on with that and solve that particular problem before you can move on to the next. If you find services that are in the way, you just have to deal with it, do the redesign, reschedule those columns, install the sleeves before you can move on to the next, because you can only work on a very small parcel at a time. In terms of local stakeholders, just thrown in for good measure, we've got two theatres. So we've got Billy at Elliott that's got performance every day here. We've got another one just around the corner. We've got large development that's starting to take place here, private developer. We've got the entrances to the station. We've got the National Rail station as well. So though there's similar upgrades happening in London, they've got the sort of the benefit of having a single island site, if you like. Ours really is quite a sprawl through this whole neighbourhood. So there's a bit of a phrase here that I think someone else has maybe copied from us in the past. But it's all about, there's so many bits of information. There's a tip of the iceberg when you start a project like this. You've got a series of record drawings, a series of as-built drawings. Then you start to do some trial holes, and that information starts to grow and grow. Then you've got the design that starts to come on. But there's still a huge amount of unknown information that we're having to deal with as the project evolves. But in terms of the information modelling, I think it allows us to model what we know that we've got there. It also allows us to prepare for what we know that we don't know. So we know that when we expose an area of services, then there is going to be information that's going to be new to us. But at least we've got that model that's there with the theoretical layout of these columns. Then we can adjust it based on the information that we get from when we actually survey the services. We can start juggling the positions of the columns, and then we can then react to the information as we uncover it. So why have we used this technique in the design? Well, actually, when you look, there's just so much massive information there that it's impossible to do it without, really. All of these are the interlocking columns here. And then we've got existing assets, we've got services, sewers, gas mains, water mains that we have to build in and around. So we start off by modelling those services. And then we've got existing the railway structure as well, and the new railway structure down here. And as you can see, some of our new construction comes extremely close to those assets, which obviously have to be kept open and running. So that's what the site looks like. As you can imagine, these things would tend to be thrown together wherever they wanted to, it seems. And then we have to put that into the model to see what space that we've actually got to work around. Each of these jet-grout columns is tagged with an individual reference number, so it becomes an actual object within the CAD model. And then that has a series of data that is then moved forward. It's cut through onto 2D slices onto drawings, but also we review the model by taking sort of dynamic 1 meter slices on the screen, so the design team can review the sort of to ensure these columns interlock as they're supposed to do. And then those 2D sections in plan appear on the drawings, which allow us to identify where these columns don't interlock. So then we can then evolve the model and rejiggle these columns around to provide that interlocking that's required. And that data is taken from the model electronically, so no more writing dimensions and coordinates down off the drawing, putting it into your book, taken out on site. That data is taken from the model into a spreadsheet, which is then used to feed into the surveying instruments to set the columns out on site. And there's also prisms on the rig itself, which are read by electronic theodolite, so the operator can see when he's got the right alignment to actually construct those columns. So as I said, each one of those columns has got an individual identification number that enables the design information to follow through to as-built information that's then fed back through the model. So we've got a full record of what's being built and what's in the ground. In terms of the future for the client, he's got obviously a long-term interest in maintaining the asset that we're building at Victoria, as well as maintaining the asset that it's already there. And there's certainly he's looking at ways in which to use that model. It's still obviously developing and evolving every day, but that will be a huge amount of quality, as-built, accessible information that he can then use to more efficiently manage the assets. In terms of looking forward, obviously we've heard this morning from ways of taking that information out into the field a lot more, and I think it's essential that we harness that model and don't just use it as a design tool, really, that it's actually taken a lot further forward into construction, into the field, so it's a lot more accessible. So it's good to see how these models have been transferable to portable devices, and really the more and more people that get to use them, and that's where the power and the value of them is, really. So as a result, this is sort of a fairly good description, I think, of what's been achieved at Victoria. It's a logistically challenging and very complex, technically complex solution, but it is being undertaken in a safe, efficient, and a very effective manner. And we've used building information in all aspects, not just the design, but certainly through to the construction, and then hopefully the client will adopt that into the maintenance of the asset as well. In terms of a couple of acknowledgements, obviously the client, London Underground, the main contractor, Taylor Woodrow-BAM Nuttall, and the jet grouting contractor is Keller, and the designer, Mont MacDonald. Thank you.
And we can take a few questions.
Transport for London have got a very incredibly detailed subterranean model for London. Is that the one you used?
Yeah, we've got model files of the existing London Underground tunnels itself. Earlier on in the design phase, before the contractor came on board, there was a series of surveys undertaken to survey those sort of back-of-house areas of the station. But the biggest problem really was those utilities. That's where the huge amount of unknown information is, and hopefully that will be captured so the next person that does work in this area doesn't start from scratch. So yes, there were building blocks of information that we started with, and then that sort of expanded as the design and the as-built excavations and surveys of services continued.
Do you have a feel for how much the modelling helped you reduce disruption on the surface, given the tight space constraints around the station? Which I don't think your photographs really did justice to. It's horrendous around there. Yeah, I think the efficiencies was that sort of recycling time. So if once we'd exposed that particular work site and found that things weren't as expected, that resource of the size that the guys that had dug that site was stood there standing. So I think that by surveying that information and get it back into the model, whether it was the design team back in Croydon, the actual structural designers, or whether it's the ground treatment contractor, they all had instant access to that information, and they could then adjust those column positions and then get the information back out on site to install those sleeves. You couldn't think of how that could be done without using the model, really. It'd be so much manual calculation work in there. And it's not just a question of design, it has to be reviewed to make sure that those revised columns will still interlock and provide the integrity that is intended for the ground treatment. So it's untold efficiencies, really, in terms of executing a project like this.
So I'll tie that back to your knowing what you know and not knowing what you don't know. It's the reaction time. Is what you're describing the payoff. Yeah,
so I think that's the key. There's been so much unknown information that's come to the surface. It's enabled to react to that information swiftly. That's the key.
Great.
Hello. Having exposed the surfaces, were you using laser point cloud scanning to capture them, or more traditional surveying techniques to build the model?
Yeah, to date we've just used more traditional techniques. We've just taken X, Y, Z coordinates and taken a manual record of what the service is and the diameter of the service. So we've got that provenance of data, which was mentioned earlier, that's extremely important. So it's just you've taken that X, Y, Z coordinate and input that into the model, and then keeping it in a separate layer of what that information is, whether it's a gas, water or sewage utility. So we haven't used point clouds for that yet. We've used it for surveying some of the other internal parts of the station, which is sort of less accessible, and there's sort of limited access to some of the mechanical rooms. So we've started to use it for that.
I think we can do one more question. All right, I'll ask it. So you were focusing here on the grout sleeves in the project. How did this activity and this modeling tie into the modeling of all the other parts, other systems that you were constructing?
Well, we've modelled the new tunnels, the sprayed concrete lined SCL tunnels within the model, along with the existing assets, and then we started off by just modelling the sort of this nominal 2-metre annulus of what the ground treatment looks like, and then as the designs evolved, that annulus has become individual column positions. So it's just the ground treatment is just another discipline within the model. So it sits alongside the architectural model, the structural model, the M&E model. So it just becomes a discipline in its own right.
Very good. Well, thank you very much.